Isip na Hub.
Welcome to another episode of our series on inferential statistics. In this presentation, I'm going to show you how to conduct one-way analysis of variance, or popularly known as ANOVA, in MS Excel. We're going to do this by presenting you a problem from which we're going to apply the test I have just mentioned.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
Let me read first the problem. The following are the final grades of 35 college students in the course Mathematics in the Modern World. These students were grouped according to their type of high school. High school pertains to either the student come from a regular high school, a science high school, or from alternative learning system. Test whether the average final grades of students differ when they are grouped according to type of school. So for this problem, we are going to compare the final grades of the students according to a type of school. So there are three types of schools. We have the regular high school, science high school, and alternative learning system. So perhaps the researcher is interested if the performance of these college students are dependent on the type of school that they come from. So since we are comparing groups, we're going to use the comparison tests that we have presented in the previous video. Let us assume that we are going to make use of a parametric test just for the purpose of showing you the test. However, in research, the proper way is to really test whether our data sets passes the normality assumption, which will tell us whether we're going to proceed to a parametric test or a non-parametric test. But in this video, let us assume that this passes the normality test so that we can show one-way ANOVA. And why are we going to use one-way ANOVA? That is because we are comparing more than two groups. Should there be just two groups, we are going to use t-test. But since there are more than two groups, there are three, the appropriate parametric test for this one is analysis of variance. So how should we state our null hypothesis? Since we are comparing three groups, our null hypothesis should be, there we have it, our null hypothesis: the mean final grades of the students are not significantly different. So it's pertaining to the three mean final grades. Alternatively, we can state our null hypothesis as the mean final grades of the three groups are equal, or by symbol, we can actually write this one. The mean of the regular group, regular high school, is equal to the mean final grade of the group of science high school, and it is also equal to the mean final grade of those students coming from the alternative learning system. So we can either choose from among these three null hypotheses, but we should only choose one. Anyway, let us proceed now to our alternative hypothesis. Our alternative hypothesis is at least one final grade is significantly different. Take note of the word at least. This means that there are more than one possible scenario for this. At least one final grade is significant when one of the three groups here have a different final grade, and the other two are not significantly different, meaning they are equal, or the three of them are really significantly different, so that this group has a mean that is significantly different from this group, the group of science high schools, the group of science high school. Also, the mean, this mean, is significantly different to that of the group of us. So they are all significantly different. It is also possible that the means of the first two groups, regular high school and science high school, are not significantly different, but both of them are significantly different from the mean of this group. As we mentioned a while back, the appropriate test is one-way analysis of variance. Okay, let us now conduct the test. Again, to conduct the test, let us click this menu, Data, and then we look for Data Analysis. This is a toolbar. We click on it, and then we select ANOVA Single Factor. There are 3 ANOVAs here, but we're going to select the first one. The other ANOVAs, it's used for other types of problems which is not covered in this presentation. Click OK, and then at this portion, this is where we put our data. Let us go back to our data. This should be our data. So let us click in, drag. We should include the labels so it would be easier when we interpret them. We click labels in the first row. Since we grouped our data by column, we should check by column. But if we arrange our data by rows, then we should click rows. Output range, let us specify where we want to put our answers, the result of the test. I want it here. And that's it. We are ready to have the results. We click OK. And there we have it. These are the result of the test. What can we see here? We have the average. These are the mean final grades for each group. So let me round this up to 2 decimal places only, so it will look more organized. We have 1.92 for the group of regular high school. For the group of students coming from the regular high school. We have 1.45 from the science high school, and we have 2.33 from the alternative learning system. And remember, these are students from Benguet State University. Their grading system is a bit different. A lower numerical grade means that you have a higher or a better performance. So in terms of average, we can see that students from this group, ALS, have the lowest performance since their mean final grade is 2.33. The group of students coming from the science high school have the highest mean final grades, but the result of the test really is found here. This is called the ANOVA Table. This is where we can see whether the test is significant or not significant. Where is that? We can look first at our p-value. So here is our p-value. This would tell us if we're going to reject the null hypothesis or not. What is our p-value? It is 6.945 e negative 0.7, but this is actually a number in scientific notation. This means that 6.945 times 10 raised to negative 7. If we're going to put this in number, we click number, then it is actually equal to 0.00000 and then numbers. But again, I'd like to emphasize that this is not really exactly equal to 0. It is just a number that is very small, and since we just rounded it up to 2 decimal places, then it would look like this, 0.00. This is our F computed. This is our test statistic. We also need this one. So what should be our conclusion? Our p-value is a very small number. Is this p-value located at our acceptance region or in our rejection region or our critical region? This is located at the rejection region. It is lower than 0.05. It is even lower than 0.01, which is our cutoff, 0.05, 0.01. So our conclusion should be to reject the null hypothesis. So if we reject the null hypothesis, then we should accept that at least one final grade is significantly different. Now, what should we report in our manuscript. If you are conducting a research, this table would guide us which of the results should we include. So we have the mean, we have the descriptive equivalent. We would know what to put here using the legend here. And then of course, we put our statistic here, F computed, and then our, of course, P value. Alright, let us copy the values. So the means are located here. For the regular group, regular high school group, this is the mean. For the science high school group, this is the mean, 1.45. And we have another 2.33. For the overall mean final grades, we can compute it using our raw data. So we have average of the entire data set. So regardless of the type of school, we're going to include everything. Overall final grade is 1.90. Let us make this more organized. There we have it. Next is the descriptive equivalent. Again, we can make use of the lookup function to automatically give the descriptive equivalence of the following means. Let me quickly do that. There we have it. We see that one final grade is descriptively very satisfactory, the other one is satisfactory, and the third one is unsatisfactory. Although overall, the students have a satisfactory final grades. For our F computed or F value, we can have it here. So we just copy it there. We have 22.82. And for our P value, we have this one. Again, convention in statistics or in research, if the P value is less than 0.05 but greater than 0.01, we actually put a single star beside the F computed or F value or the test statistic in general. However, if it is lower than 0.01, we put a double star like this. The double star means that it is highly significant. We are almost done with our analysis. Our conclusion is that at least one of the means are significantly different from the rest. I said almost done because if at least one of them is significantly different from the rest, which one of them? Some researchers would base it on the means that we see here. Since this group have the highest mean, the science group, then perhaps this is the group that is significantly different from the rest. But there is a problem with that. What if the two means, the first two means are not actually significantly different, and that the significant difference that is detected in the test is pertaining to a difference between science and the ALS group, but not between the regular and the science group? Or perhaps all the three means are significantly different from each other that we do not know. This is the reason why, after conducting an analysis of variance and the result is significant or highly significant, a follow-up test called a post-hoc test or a multiple comparison test should be conducted. Unfortunately, Excel do not have a program or a function for us to conduct this test. What are some post-hoc tests? We have the Duncan's multiple range test, Tukey's SHD, and we have the Schiff's test. In other softwares, we can actually conduct this one. For example, we have SPSS. We can directly compute for the result of the post-hoc test. We have also the Stata and R. But as I have said, unfortunately, Excel do not have that ability to compute for the post-hoc test. What I'm going to do, just to show you an example of a post-hoc test, is an online calculator. Let us search the net for an online calculator that can perform a post-hoc test. So let us type in Posthoc Test calculator and let's see what appears. I have tried the first one, ANOVA with post-hoc Tukey HSD test calculator with this one, Shife. Let us click this one and see what happens. Okay, the first thing that it will ask us is to select the number of independent treatments below. So this means how many groups are we comparing. So since we are comparing 3 groups, then let us click 3. Let us uncheck this one. This is important. If we do not uncheck this one, it will still assume that the value of k is 4. That's the default value. After doing this one, identifying the number of groups being compared, let us proceed to enter our data. So we click this button. Clicking this button, we'll see a space where we can put our data. So we have the 3 groups. It has 3 columns because we have identified earlier that we are only comparing 3 groups. What we're going to do here is to copy our data. We can just copy and paste our data in our Excel here. So let me copy the first group. There we have it. And then we do the same for our other groups. So remember that sample A is our regular high school, sample B is our science high school, and the last one is the ALS group. There we have it, our data. And then the last thing to do is to click calculate ANOVA with Tukey HSD and then Shife, Bonferroni, and home multiple comparison. These are other post-hoc tests that we can use. For this specific example, we are going to interpret Tukey HSD. Click it and it will give us the answers. Let us look at the first results. We have the descriptive statistics. Also, we have the... what are these? This is the ANOVA table that we calculated before. So if we look at it, it's the same values that we computed a while back in our Excel. The F statistic is 22.82, which is the same value here. Let us compare that one. Let me organize our window. Okay, so if we notice, we have the same result. P-value is the same as our value here. We just rounded this a while back into number. Let's bring it back. This one. So we have 6 point something raised to e raised to negative 0.7. Our F statistic or F computed or F value is the same. It's 22.8164. So it's the same values. Since we are done with these values, we do not really have to look at this. Actually, our goal here is again the result of our post-hoc test. So we are done with this one a while back. So here is the result of HSD. So what we see here is actually a pairwise comparison between the 3 groups. Since there are 3 groups, there are 3 pairs. Let us copy this result in our Excel so we could interpret it easier. These are the results that we had by conducting a post-hoc test online. This is Tukey's HSD. So what does these results mean? Remember our coding here. This is ABC. A for the students of the regular high school, B for the students of the science high school, and C for ALS. We see that this post-hoc test is comparing the 3 means pairwise. Since there are 3 means, there are 3 comparisons. The first one is a comparison between A and B, these 2 groups here. And according to the test, we have a significant difference. Therefore, we should put a different letter between the 2 of them. Since this group have a higher mean, it should have the first letter A. And then we have the letter B for the second mean that is significantly different from the first one. Next test, A is significantly different from C. So A and C, they are significantly different, so they must have different letters. Since B is already used, then we should use the letter C. Also, B and C are significantly different. They have different letters. One has A besides it, and then the other have C, letter C. What if one of the pairwise comparison, A, resulted insignificant, meaning the two means that are being compared are not significantly different? How should we indicate this in our table here? Since A and B are not significantly different, then they should share the same letter. Unlike in this case, since A and B, when we compared it here, they are significantly different, meaning they should have a different letter besides them. That's not the case here, so let us put the same letter besides them. They should share the same letter. Let me do that quickly. Okay, there we have it. They are sharing the same letter. Again, that means that they are not significantly different. We have the second comparison, A versus C. According to our post-hoc test, they are significantly different, double star. That means that they should not share the same letter. So we should put, what's that letter next to A? It should be letter B. There we have it, 2.33, and then beside it is the letter B. That means that A and C, group A and C, these groups are significantly different. The last comparison here, that's between B and C, or this group and this group, they are significantly different. The probability value is less than 0.01. They should share a different letter, and indeed, they are sharing a different letter. So that's how we do it. Now, what if we have the same problem? However, our post-hoc test indicated a different result. So for example, we have two insignificant results in our post-hoc test. So this is also insignificant. Let us go over this one step by step. So the first comparison, A and B, this group and this group, they are not significantly different, so they should share the same letter. So they do share the same letter. Both of them have A beside them. Next comparison, A and C. Group A and C. They are, again, not significantly different, so they must share the same letter. And since C, group C has letter B on it, then A should also have a letter B beside it. So this mean should have A and B beside the mean to indicate that it is not significantly different from this group, also not significantly different from this group. So let me change the first mean. Let me repeat what I just said. This mean is not significantly different from this mean, the middle mean, 1.45. We know that because they share a common letter, that's A. Also, this group, Group A and Group C, are not significantly different. That's why they are sharing a common letter, B. B and C are significantly different. This is the only pair that is significantly different. That's why they share a different letter. So that's how we do a multiple comparison or a post-hoc test. A post-hoc test again happened because our p-value in our analysis of variance here is significant. But what if it is not significant like our data here? If we conduct analysis of variance with this data, it's the same problem, but we have a different hypothetical data. Let us run analysis of variance with this data and see what happens. We check columns, labels, check. Our output range is somewhere here. Let us look at our data. These are the averages. If we are to report this one, we need it. Also, our F value or F statistic. It is 2.11, and of course our P value. Our P value is actually high. It's 0.14. It's higher than 0.05. This means that the means of the three groups here, these means are to be regarded as equal. They are not significantly different because again, our P value is greater than 0.05. And since that is our result, we are going to accept the null hypothesis that all the means are not significantly different. They are equal. For this case, we do not have to conduct a post-hoc test. That's all for our presentation. Thank you for listening.